Chapter 5, still in the continuity. This is video number 3. Now in example 4, we're still in identifying continuous functions. One of the three functions in this slide is y equal 1 over x, such that 1 over x is a continuous function because 1 over any value is defined value. So it is continuous for every point in the domain, except one point, which is called the point of discontinuity. It is x equals 0, because 1 over 0 cannot be defined. So then, this function is called continuous function, and it is not defined in just one point. The function f of x equal x, or which is called the identity function, is a continuous function, since we take any value for x and its image is the same value. And when we graph it, it is a straight line and has no gap. Even the constant function, it is a continuous function. And for example, here we got f of x equal 2. So for any value of x, we choose it. Suppose that it is negative or 0 or positive value, then the result is f of x equal 2. Then the ordered pairs negative 2 and 2, here is negative 2 and here is 2, so this is the point. 0 and 2, this is the point. 2 and 2, this is the point. These are 3 points. If you connect between them by using your ruler, you will find that it is a straight line, and this straight line is parallel to the x-axis. This is also a continuous a continuous function for any value for x. Now, if we have more than one function, this is called combining functions. Now, if we have f and g, two continuous functions, both of them are continuous at the same point, x equals c. Then, the sum of f and g is continuous function, and the difference is continuous function. Even their product is continuous, and the multiple of f or g by a constant will give us a continuous function. And if we divide a continuous function by a continuous function, it will be continuous except when the denominator is 0. And if we raise f to r over s, where r and s are integers, then such that the interval that the function is defined on it containing c, so then the function that is in the result is continuous function. Now another type of continuous function, this is the polynomial function. This is the formula of the polynomial function. So any polynomial function is continuous. Thus, because we substitute the value of x in the terms of the function, so the limit will be equal to the value of the approached value for x in the polynomial. So then the polynomial function is continuous function. Even what is called rational functions, such functions are continuous. We took it in the previous slide and we said any two continuous functions, if you divide them, then the quotient is continuous, such that the denominator should not be 0. This is also going to give us continuous function. In example 6, another type of continuous function is the absolute value function. The simple absolute value function is f of x equal absolute of x. Now this is continuous for every value for x. If x is positive or negative, even if x is 0, so it is continuous function. Also, we have the functions sine and cosine. Those two functions are continuous functions for any value, even by x equals 0. So that's why they are continuous. Other types of trigonometric functions has continuity and discontinuity values. For example, when we talk about y equal tan x, as we know, the tan is sine over cosine. So if the cosine equals 0, then the denominator is 0 and it will be undefined. And thus satisfies for specific angles pi over 2 and 3 pi over 2. These two values will give us denominator 0, so then the tan will be undefined. That's why this function tan x is continuous on the union of open intervals from negative pi over 2 to positive pi over 2, then pi over 2 to 3 pi over 2, but the union without the specific values in the ends of the interval, because they will give undefined values as we explained here. These exercises are given in the book. We will talk about how to find the continuity of them using the extensions. What is the extension? Means that take a function and you will see that the critical value is making the denominator 0. So how can we solve this problem? This is what's called the extension, and it is adopted on factoring denominator and the numerator and simplifying them. We will solve these exercises in the next video.